Can you hear me? Cool. Nice. So thanks for coming, and thanks for choosing this talk over the others. I hope that I will meet your expectation. So today I would like to talk about next generation of front-end architecture. So basically, we will have a journey through communicating sequential processes, and then we arrive to reactive programming, and probably one of the first client architecture that currently is available in the reactive world. My name is Luca. I'm Italian. I live in London. I'm a solution architect for The Zone. The Zone is a new service that currently is available in 4 countries. And basically, we define ourselves as Netflix for sport. I'm a Google developer expert on web technologies. And I'm the community manager of the London JavaScript user group. So if you are in London and you're looking for a nice evening hanging out with a few people, check meetup.com and you will find us. So today we are going to cover, first of all, an overview of what is the current situation of the front-end architectures. We will talk briefly about communicating sequential processes. We will introduce reactive programming. And we will close the day with model view intent, that is MVI. This new architecture, completely reactive, and probably one of the first one for the reactive world. So let's talk about architectures. I think that talking about the first architecture everyone, I think, is familiar here, is interesting because in the 80s, we started to work with MVC, model view control. And as you know, MVC is well-known and well-used by everyone. I think currently, a lot of applications are still made with MVC. It's interesting because the controller in this case is handling 2 different objects, the model and the view, and the view is updating the UI through the data that are present in the model. So the view has a direct connection with the model. Later on in the 90s, a new architecture, a new pattern came out that was the MVP, probably my favorite one. Is model view present. In this case, we have a new design pattern introduced that is the presentation model. And the presentation model basically is completely hiding the model and the view. So the only way to communicate between these 2 worlds, between the model and the view, are through the presentation model. The interesting part of the presentation model, in particular if you work in cross-platform application, is that the presentation model has a lot of responsibilities. And that means also that the presentation model is able to interact with the view. It has completely the state of the view. It handles the state of the view. And usually the presentation model has a correlation 1-to-1 with the view. So that means every time that we have a view, we have a presentation model, and then we have a model that is handling the different views. It's pretty cool because usually here the view is a dump view. So it's what we call, Martin Fowler used to call passive view. And that means at a compile time or a transpile time in JavaScript, potentially you can swap the view and have a completely different application with completely different views, but maintaining the same behaviors. In 2005, Microsoft came out with a new design pattern. This architecture is called model view Viewmodel. And again here, they are leveraging the same concept of before, where instead of having the presentation model, we have a view model. This one is still largely in use today, in particular for mobile applications. Let's think about iOS, for instance. It's interesting because in this case, there is, in order to the view is not dumb anymore, is more responsible and more aware of what what is the world outside it. And the interesting part is, in order to update the view, usually there is a binding system between the view and the view model. Again, the view model here is handling the content of the view. In 2009, the same creator of MVC said, yes, MVC is a super nice architecture, but it's quite old and is not representing anymore what we currently should create in the software world. So he came out with the DCI, Data Content Interaction. DCI is one of the most famous lean architecture. And the interesting part is here we are not talking anymore about model view or the language of the computers. We are talking about data, context, and interaction. So something that is more easy to understand for people that are working on the business side of software. So usually you have a data that represent, of course, what you have to show inside your application. You have interaction, that is basically how this data and the user are interacting together. And you have a context that define how these two elements are dealing together. And then in 2013, Facebook came out with Flux. Flux is often referred to an architecture, but currently Flux is more a pattern. Flux pattern basically is leveraging the concept of unidirectional flow. And unidirectional flow means that when the user is interacting with the view, there is a unique flow that is following these actions in order to retrieve the data and update the view. And in this case, it's very interesting because that leads to model view intent, so MVI. And we will see later what model view intent is. It's pretty recent, as you can see. It was created a year ago by Futuris. It's a company that is present in several countries. I think the headquarters is in Sweden. And there is a really nice post that talk about MVI. We will see that later. But what are trying to solve this architecture? So which is the main aim behind this architecture? One of the main aim is the object communication. So we try to solve, to decouple the different objects and to find a nice way to communicate together. Because if they are decoupled, that means that they shouldn't see each other. But at the same time, we want that these objects are communicating together. Usually when we work with this architecture, we have several ways to communicate together, and we can use events, we can use signals, we can use a pub subsystem, we can use, like in Flux, action and a dispatcher. There are several ways. I would like to introduce you to other two ways today. One is the next one, the communicating sequential processes, and the other one is the reactive programming way through the model view intent, through observables, precisely. So communicating sequential processes is not something new. It's something that was created in 1978, so it's pretty old, right? There is currently a library, there are several libraries in the JavaScript world. My favorite one is CSP.js, that is a porting of Clojure, in particular of the Clora Sync library of Clojure, and the Go, in particular, for the Go routines. It leverages the concept of composition or inheritance, so nice to test. And it's completely loose-coupled. It allows you to well encapsulate your object and create clean and reusable code. CSP, as I said, it means communicating sequential processes, but it's quite misleading as name because it's not only sequential processes, but also parallel processes, as we can see in a moment. So how usually it works? So think about CSP like a broker between a communication between two backend elements. So when you have a broker, usually it's in the middle that is allowing to communicate to microservice, for instance, or whatever. So in this case, it's the same concept. We have a channel that is injected inside the view, inside your controller, presentation model, whatever architecture you're using, and we are using the channel in order to communicate with the two models. I prepared a quick demo just to give you more feedback on that. Let me start this demo here. I have a few demos today to show, as you can imagine. OK, so this one is a simple bingo system. I don't know how many of you are familiar with bingo, but basically it's a game that there is a user that is buying some tickets, and there is an engine that is calling some tickets. Every time that a number is called by the engine, you have to check if inside the user ticket there is this number. When you have 5 of these numbers inside the ticket, you win a prize. Nice and easy. So what I created here is basically 2 tickets. These are 2 arrays with some unique numbers that could that start from 1 to 99. This is the rule of bingo. And then I have an engine that is calling every few seconds a number. And when a number is present inside the ticket, I'm just saying, oh, got a number 41 in ticket T2. That is the ID of my ticket. So how it works? Here we have a particular problem because everything is asynchronous, right? So we receive every now and then, potentially from the server, in this case I'm faking it directly from the client, a number, and we are checking in a different object that could be created at the beginning of the game or during the game, because potentially in bingo, a user can buy a ticket also during the game. Obviously, the tickets are randomly assigned, so you don't know which kind of numbers you will have inside your ticket. So let's take a look to the code that is interesting. Here we are. Can you see it? Is big enough here on the bottom? Cool. OK. So basically what I have here, I have the first application that is creating a channel, because communicative sequential processes are based on channels. And then we are wiring the channel together, and we are creating the bingo system. What does it mean, this? So basically, I'm creating 3 different channels. One is for the engine, another one is for the first ticket, and another one is for the third ticket. What I'm doing is transforming my CSP that by default is unicast to a multicast channel, and is starting to share the value that are inside this channel across other channels that are injected inside the tickets. So what I'm doing here is basically transforming in a multicast channel my main channel, my engine channel, and then I am injecting it. I'm saying, yes, you have ticket 1 and ticket 2, you have to rely on the multicast that I've just created, and then I'm injecting the different ticket inside, sorry, the different channel inside the ticket. So that means, as you can see here, there is a clear separation. So the ticket by themselves, they don't know that that an engine exists. They just know that there is a channel that is communicating inside, and inside they can find some values. So if I check the ball consistent, so the engine, let's check what it's doing. So here, as you can see in the constructor, I have a channel that is injected, and I'm starting the system creating 40 unique numbers. And every 3 seconds, I'm calling this send data function. Inside send data, what I'm doing is just retrieving one value inside the array and passing this value that is a number inside the multicast channel. And then, because the communication is through the channel, and are the channels that are handling this communication, I don't need to call a specific method in the ticket. I don't have to know that there are tickets outside there. I'm just taking a value and put inside the channel, and then someone is listening to it. And that's it. Really easy. And as you can see, we have a real separation of concern here, because no one knows about the entire system, how it works. Then, after sending this information inside my channel, I'm increasing the operator and the counter, and checking if the counter is bigger than my total calls. And if it is, in that case, it means that I have finished the game. Nice and simple. What I'm doing in the tickets instead is injecting a channel and ID just to understand what kind of ticket is handling that. I generate 15 different numbers, because each ticket has 15 different numbers. And through a Go routine that is, through a coroutine that is a new syntax that we have in ECMA 6, I can check the value and understand if the channel is closed. And when the channel is closed, I will say, OK, I don't listen anymore to this channel. But at the same time, what I can do is checking if there is the number inside my array. And as you can see, these 2 objects, so the ticket and the engine, they don't know each other. And that's the real powerful thing of this. The other interesting thing of CSP, we will see in a moment, is that with this channel, I don't use them only to communicate between different objects, but I can also do more things. So for instance, I can set a buffer inside the channel. So I said before that, for instance, I can have a user that is buying a ticket during the game. So after that, a few numbers are called inside the game. But what I need to do is checking if these numbers are present inside the new ticket. And potentially, I can do that easily without creating complete complex logic inside my application, just saying to my channel that it needs to take a buffer. It needs to take all the numbers that are spawned inside the application and thrown inside the channel, keep them in memory, and then check every time that a new ticket is created or is added inside the game logic. I can insert a value inside a channel. I can retrieve a value inside the channel, as we have seen. I can close a channel, or I can close a channel after a few milliseconds. I can, for instance, split, merge, or pipe channels, and that's the real power. So potentially I can say, okay, during a specific moment of my application or during a specific view, I have two channels that are not communicating together, and I can merge together because they need to listen to a specific information that are passed through another channel. And then I can say, okay, in this view I need to merge them, but in the next view I have to split them. And I can do that without impacting the business logic of my application. I can create a pub subsystem, so more or less an observer pattern. I can broadcast value simultaneously or in parallel. It's up to you. I can also do some nice thing that are called transducer, or a transducer basically is a concept that it means transformer and reducer. So inside the channel, potentially, I can transform data before they arrive to the view. So potentially, I can say, oh, you know what? Instead of passing just a raw value like an integer, I can change it and decorate it with adding some more information. Or I can filter this value. So all the value, instead of saying, OK, I have to retrieve all the value and create a sum inside my view, I don't need to do that in the view anymore. And I don't need to do that anymore inside the model. I just need to do that inside the channel. So that channel became a reusable object that I can use in different sections of my application. I can avoid to duplicate data because the transducer allow me to say, OK, if I send twice the same data, you just pick one occurrence. And I can decorate data inside the channel. It's pretty powerful, as you can understand, and create a nice separation of concern. And the interesting part is, in my opinion, CSP are not well known inside the front-end community, but they should be, because they are the ancestor of what reactive programming is. And let's talk about that for a moment. So what is reactive programming? So reactive programming is a programming paradigm, first of all. And as you know, probably there are several programming paradigms. There is imperative programming, functional programming, and now reactive programming. Imperative programming is what we have seen when I describe the logic of my engine. So I basically say, every line of code, I'm describing exactly what I want to achieve. So there isn't any magic. I'm just saying, yeah, you have to iterate through this, you have to, I don't know, add a specific value in this particular situation, you have to call that specific function, and so on and so forth. In functional programming, we slightly changed this concept, and instead we are leveraging the fact that we are using mainly functions, and the interesting part is that these functions are pure. So that means there is a predictable outcome from this function. When I call a function with always the same argument, I will have always the same result. There aren't any side effects that are created by a pure function. And that is pretty good because it means that our code is predictable, and also on the test side, we can easily test our stuff and be sure that if I'm testing a pure function and if I pass a specific value, it will not change any state inside my application. What is reactive programming then? Reactive programming is used mainly for leveraging the concept of time inside an application. So the interesting thing is reactive programming has, at the beginning in particular, not an easy learning curve, mainly because there are a few different concepts that you have to understand before you move to reactive programming. And currently, to be honest with you, I didn't see many talks like this one that are talking how to create a full application in reactive programming. A lot of them are talking about RxJS. A lot of them are talking about MobX or different libraries that you can use in a reactive way, but usually you use in an imperative programming application. Here we are trying to leverage a different concept. So here we are saying, so when we work with imperative programming, for instance, usually we, inject an object and we start to say, okay, I injected the B inside A, and from A I'm saying B.method. This is how I usually work, right? So here what we are saying, and this is more or less the same concept that we have with CSP, A and B, they don't know each other, but they are communicating together. How they are communicating is the clue of reactive programming. And usually what happens that there is something that allow A and B communicating together, and when B is listening for a specific event that is happening, maybe created by A, is reacting to this change and is doing something else. And is communicating with other part or other object of my application through always the same way. And in this case, what it is this way to communicate together are streams. Streams is a really powerful concept because basically it's a sequence of ongoing events. I will show you a demo just to give you an idea of what I'm talking about. Let me take down this and start this. Okay, so if I refresh now, I have this nice div that I'm moving away and retrieving the position of my mouse, and whoop, something happened. So now, if I move my mouse, nothing is happening. So my div is still there. So what we have here? So here, what we had basically, let me see if I can show you from here. Nice. This is a really stupid example that I created. So what I have here is this. So usually when you want to listen to a mouse move, you add an event listener and to the mouse move. And then what's happening, you are calling a callback every time that something is happening, right? So when the event is triggered, the callback is called and job done. Here we have something different. Here, what I'm doing is rx.observable from event. So I'm basically transforming my event to an observable object. And I can start to use the observable as communication channel between my view and the business logic that I want to use. And after a certain amount of time, so in this case 5 seconds, I unsubscribe. I don't care anymore to talk with, to listen to this mouse move. And I'm doing everything in, let's say, in a functional way where basically I'm calling different function. I'm passing a specific argument. I'm returning always the same result. Nothing more, nothing less. It's slightly difficult sometimes to approach reactive programming, but trust me, the benefits are really, really big. So let's move back to the slide for a moment. So as you can see here, everything can be a stream. So all the events that you have currently, that we're using currently and a listener, you can transform in an observable, and you can use the power of observable and do whatever you want. What can you do with observables? The same thing that I explained before with channels. So you can merge them, you can change the value inside them, you can do really a lot of things. But in this case, as you can understand, you are isolating the change inside an observable instead of spreading the logic across your application. Usually, a stream is composed by some value that are passed inside the stream. You have a completed signal that it usually, this one is what we call in reactive programming a marble diagram, or marbles. And we are using that to describe in a certain amount of time what's happening. So in this case, for instance, I can tell you that in this amount of time, inside this channel, I receive in a certain moment at the number 1, then the number 2, then the number 3, after a while, then the number 4, and then the stream was closed. So no one can listen anymore to this observable. This is a nice way to understand how the things work. There is an interesting website that I suggest that is called marbles.com. It should be, where you can understand how you can merge different different stream together and do manipulation of data inside this channel. Another concept that I have to move back here. Another concept that you need to understand is basically all the reactive programming and all the observable are based on observer pattern. The observer pattern is, in particular for front-end developers, should be well known, because what we are doing is just saying to a subject object that I'm subscribing and listening to something that is happening inside the application, to the subject in this case. And when I don't need anymore to know what's happening inside the application, I just remove myself to listen from the subject. It's very well known, I think, in Java. I use quite a lot because I have a background as ActionScript developer, and this one saved me literally my ass several times. There are other two concepts that are very important to understand in reactive programming. The observable could be cold observable or could be hot observable. Cold observable usually are used when you want to communicate in unicast. So the interesting part of cold observable is that the producer is created when an observer is listening to an observable. So when an observer starts to listen to the observable, in that moment, the producer starts to pass the data to the observer. And this one usually is completely unicast. Instead, the hot observable is multicast. So in that case, the producer is outside the observable and is spread across multiple observers. So in this case, I have different observable that are listening, different observers that are listening to the same observable. Which is the main difference between that? So what I did, basically, in this case, is comparing the application that I've just showed, so my bingo system, from... first, let's start with the final outcome. I need this, and if I go here again, let me have the console back. OK, again, here. I have two tickets. I have my engine that is starting to call some numbers, and I have my tickets. So for instance, 3 is present ticket 2. Same outcome, right? OK, let's see the code. That is the most interesting part. OK, so let me close this, and let's move to this one. What we have here, so here again, we have a ball call system. We have 2 tickets. They don't know each other again. As you can see here, we have an engine. We have the ticket that are just listening to a stream, nothing else. How it works, my engine. So here, what I have is this. So instead of having all the complex logic that I'm describing step by step what I'm doing, I have an observable that is creating a way to communicate between the engine and the rest of the application. I say, you know what? Inside this observable, every now and then, so I create an interval, and this interval is 3 seconds, again. You have to return the value inside a specific array. This array is exactly the same array that I had before. And all the data flow is living inside the observable. It's not spread. It's not keeping any state. Everything is living inside the observable. And when you spawn every 3 seconds 40 elements, it means that you have to stop to spread values, and you have to complete your life and close the observable. Then I have to do this stream publish, and I will explain in a moment why. Mainly because there is a reason why I want to do that. Because I want to show you how easy is dealing with the problem that I explained before. So someone that is buying a ticket after a while when the application started. So in this case, what I have, as I show here, I have my 2 tickets that are created right after the engine, and when all the tickets are available, I start my game. Fair enough, simple thing. What I have inside the ticket, again, I pass this observable, and what I'm doing is subscribing to when the observable is producing data, when there is an error inside the observable, and when the channel is closed. So when the stream said, OK, it times to the game is over. And just that. And then I'm defining the different variables. So what's happened if instead of creating straight away ticket 2, I'm just doing that. So after 5 seconds that the game starts, I want to have the user that is buying, I'm simulating that the user is buying a new ticket. So what I'm having here is one ticket. So you see, I have all my tickets. I already call few numbers. So I have 17 that is already called. I have 27, 9, and 82. And then I have the second ticket both. But the first 4 numbers weren't checked to the second ticket. So as you can see, then I will start to check number code 77 in ticket 1 and ticket 2, and then 49, and so on. And so basically, I have a bug inside my application, and now I need to fix it. So I need to find a way to check this amount of this number that were called before when a new ticket is called. So in reactive programming, in imperative programming, you have to create quite a lot of logic in order to solve this problem. In reactive, you don't. So what you are doing is basically this. Instead of doing all these nice things here, I created what is called a system replay. A system replay is just keeping a buffer, it's buffering all the numbers. Think about how you would solve this problem in a different way. So what I'm doing here is having this object here, both called system replay, and it's even easier. So if we compare this with my other system, that is the other engine. So in the first engine that I showed you before, what I'm doing is interval map take. Okay? I have to create a buffer for my observable, for my stream. What I'm doing is here interval map take, and I add just share replay. Job done. So the moment that a new observer is listening for that observable, because I said that he has to replay, automatically it will pass all the buffer of number and check all of them. So let's see them. Let's see it in practice here. Did I save this? Yes, I did. Cool. So let's compile again. I move here. First ticket, I'm starting to call a few numbers. Second ticket, let's see here. The first thing that he did when I added the new ticket is just checking, again, the same number that were there. If you have to do that in imperative programming, you have to create the buffer. You have to check this buffer every time that a new ticket is created. Here, with the method, you solve all your problem. And also, if we compare this code with the previous one, where we are describing each single step, you can see that the verbosity of the imperative programming is not definitely a good thing, because yes, at the beginning it's easy to understand, but in the long term you can have more bugs. I listened to a talk I think this morning, where they were saying more code equal to more bugs, right? So what we are trying to do is having something that is dealing with asynchronous data, and the vast majority of the front-end application are doing that. And they need to solve that in a nice and easy way, and also without create a lot of bugs. This could be a nice way to do that. So let me stop this, and let's move forward with my presentation. OK, cool. We are completely on time. OK, cool. Model view intent. So this one is the architecture that currently, in my opinion, is representing better the reactive movement in front-end. The interesting part of this is, if we compare with MVC, that is, I think, common for everyone, usually we have a controller that is handling the view and the model, and the view is reacting or is updating the view from the data present inside the model. And it's quite common, and I think everyone here has used it at least once. What is leveraging MVI is this, having a completely different flow. So if you remember, when I started my talk, I was talking about Flux as unidirectional flow architecture. And here we have exactly the same concept. So here we have the model view intent that has a unidirectional flow, where we are splitting completely the model, the view, and in this case, something subtle, because we have not only the view, but we have also the renderer. So usually when you work with MVI, you usually work with a virtual DOM. I think if you're using React, probably you know what a virtual DOM is, but there isn't only React as a virtual DOM library. There are several of them, and we'll show you in a moment another one. And the interesting part here is that the view basically is containing the virtual DOM, so how it should represent the view. The renderer object, or the library in this case, is the one that is going to manipulate the DOM. The intent is listening for the events that are triggered by the view. So if the user is clicking a button or roll over on a specific thing or, I don't know, interacting with a drop-down, the intent is going to listen to them. Is preparing all this data for the model. The model is updating its state, or the application state, and then it can pass this information to the view. And all the communication of these things are not objects that are talking each other, are made only through observables. And that's the interesting part. So let's see it in action. Let me move here. So what I have created here is this. I don't need that. So this one is real-time data that I retrieved from London Tube. And as you can see here, basically, I have my Piccadilly line, that is one of the lines that are present in London. And I can see all the different destinations of the trains. I group them together. And I can see when is the expected arrival time. I can see which is the station, the current station. Which is the current location, in which platform they are. And this one is refreshing every time that retrieve new data. So if we wait here for a while, we will see that refreshing. I can also force the refreshing and change the library, the line, and go to Elephant and Castle. These are real-time data. So if you try right now to check inside the TFL website, you will find exactly the same information. So how did I do that? So let's move back here. Let's close this, and let's move to the last example of the day. OK, so what I'm doing here is this. So I use a framework, is a functional reactive framework called Cycle.js. Cycle.js is probably one of the it's quite new, it's recently new. They already write a couple of versions of it. The last one, in my opinion, is brilliant because if you are passionate about observables, there are currently several observables library available in the JavaScript world. There is React.js, MobX, Xtreme. And currently, this architecture could be used with any of these library. And that's the cool part of Cycle. Cycle is just solving one unique problem, as the name is saying, that is cycling the code inside the architecture. So what I'm doing here is having the first application that usually Cycle, it works in this way. So you have, it is completely functional, so it works with pure functions. And each function is just returning some observable. So I have as argument, as input of my function, an observable, or an observable of observables. And I return an object containing observables. And the cool part, when I finish that and I want to manipulate the view or I want to interact with the network, I have drivers that I can plug. And this is a fractal architecture. So that means I can compose my application just nesting different components that are based on MVI. So that means potentially you can take an application that you have created and insert inside another Cycle application without thinking about how I can refactor that or how I can add this new functionality, because you just work in like a Russian doll, if you want. The interesting part here is, again, I'm dividing my application in view, mod. As you can see, they are not objects, they are functions. It's completely different, the concept here. And intent. And how I said, as I said before, basically I have the first the beginning of the application that receives some drivers. Basically, in this case, are the driver for communicating with any Ajax call, and the other thing is rendering the virtual DOM. That is this guy here, DOM and HTTP. What I'm doing here is basically the first thing is, let me show network, is process the response. So again, there is a driver that is helping me to say everything is an observable. Again, so we can do a lot of things on that. So in this case, for instance, I'm selecting which is the code that I'm doing. Because I'm receiving multiple value, I'm flattening it. And I'm just saying when you receive the last value, I just parse the content of my JSON file, and I return that. So the return of the response will be exactly this. So my data that I retrieve from the endpoint, right? So then what I'm doing here, I'm passing to the intent. As I said before, the intent is responsible to listen to the user interaction inside the view. So I'm passing the DOM object, sorry, the DOM driver. And what I'm saying here is, here we are. I had my drop down and say, OK, listen to every time that there is a change event to the line object. I'm selecting the element. And then when you have that, every time that is changing this, you need to return some value. And I create this object that is containing this value. And again, there is this finish notation, how it's called, because the creator is from Finland. The finish notation that is used usually to express inside your code that you're using observable. So this variable contains an observable that is $, at the end of the variable. So usually when you see variable $, it means that it contains an observable or an observable of observables. When I'm here and the intent is listening to that, is returning the response and what is happening to the action. The action are passed to the model. So the model is containing the response of the HTTP and the change that are made inside the DOM. Inside the model, what I'm doing is retrieving the data. I call this function that is a normalized data because obviously what I receive from the TFL website are all the data but are not aggregated, are just a list of elements that I start to aggregate per destination station. Again, here I just want to show you that you can use functional programming, but you can also use imperative programming with this. So in this case, for instance, I'm not using I can do exactly the same thing with an observable. But in this case, just to show you that you can mix and match these different techniques. Here you can have, let's say, classic and super normal way to sorting an array, and then returning this data to the application. Let me move back here. So is normalizing the data, is preparing, let's say, all the data together. And because I have different observables, so I have the response and I have also the interaction made by the user, because I'm defining that is Piccadilly line or Bakerloo line or wherever it is, I'm saying, OK, I need that you combine these two information in a unique observable. So in this case, I'm merging this observable in a unique observable that contains all the information. And the cool part is, oh, you know what? The first time, please, because when the code arrived to this place, I didn't select a line, so start with the default line. That is, sorry, this one. So basically, I can also say if inside my observable the value is null, I can put a default value. And it's pretty powerful, to be honest. And then what I'm doing is, when I merge all this data, I prepare my new state for the view. I'm passing this state, and again, the view is containing the representation of the virtual DOM. So what I have here, template, is this. So here I'm using a library that is embedded with Cycle.js that is called SnapDOM. It's pretty powerful. It's leveraging the same concept of React with the virtual DOM, but it's faster. So if you're looking for something that is faster, or you have to run a virtual DOM diffing algorithm in, let's say, a device not very powerful, SnapDOM could be an answer for you. SnapDOM allows you to work in this way, so creating your real DOM through function, or you can use JSX. Completely up to you. Here, what I'm creating is a div that contain my select, and the interesting part is this. Again, in a completely functional way. So I pass some data to my render train. What I'm doing is calling different functions that are creating my real element, my virtual DOM, that then is rendered by SnapDOM inside the view. And that's why I add the representation inside the view. Last but not least is check if there are other requests. And then I pass everything that is made inside app method to my drivers that are doing the real side effect. So the side effect is made by the two drivers, in this case DOM and HTTP, and are dealing with that. As you can see, if I want to test this thing, it's very easy because each function is doing one specific thing and are receiving a parameter and is returning, again, always the same parameter. So I know that these functions are pure. Let's move back here. I think I have, yeah, perfect time, incredibly. The interesting thing is, can I use communicating sequential processes and reactive programming in any project? Again, currently I saw in the JavaScript community that there is this idea that using React or React.js means, oh yes, I'm using reactive programming. That's not true. Reactive programming is another thing. React is misleading. It's something that was, yeah, the name is misleading. It's not related to reactive programming. But usually when you think, let's say it's a mind shift working with reactive programming. As you can see, it's not anymore just taking a library and put inside there. So if you're using Angular 2 and React.js is embedded by default inside the framework, it doesn't mean that you're working with reactive programming. Reactive programming is using a different paradigm. It's leveraging different concepts from imperative programming, and it could mix and match with imperative programming or functional programming, and that's the cool part of reactive programming. But starting now talking about reactive programming or working with reactive programming in a nice way, it means that you will have the possibility to use it in several projects, and you can make the difference in the reactive community. Just to give you an idea who is using reactive programming or who is using these techniques, I think that everyone here heard about Netflix. So React.js is created, React.js 5 is created or is handled and created by one of the senior engineers in Netflix. And currently, the interface that you are using on TV and on browser is made in a reactive way. Because all the state and all the things are handled inside the server, and then the view that is usually running in not very powerful devices, in particular if we are talking about, I don't know, Apple TV or Samsung TV or stuff like that, they need to react quickly, and they need a light code that allows you to do a lot of let's say, a lot of communication and react to how the data are changing, in particular because when you have, for instance, your catalog present inside the view, every now and then there is a refresh of this catalog, and you have to deal with long polling, stuff like that, or socket, even worse. So you don't know when these information are arriving, and if you are working in an imperative way, this could be tricky if you are not, in particular if you have a large team, if you are not very strict in the way how you are working with your code. So reactive programming definitely is leveraging new content and is leveraging new concepts, and I think it could be definitely the future of this industry, and not only on the backend. In backend is been a while that they're working with that, and currently another interesting thing, if we are talking about React.js, is not available only for JavaScript, but it's available also for Java, Swift, C#, and several other languages. So it's pretty much really a way to think your programs, your software, instead of just a library that I'm using on the spot just to solve asynchronous communication with the server. So definitely, yes, I suggest to spend time understand if your project that you're working right now needs to work with reactive programming or not. But again, it's just another tool that we have on our belt that we can use when needed. But we have to be conscious that, yes, it's a buzzword right now, but it doesn't mean that you have to use everywhere. So that's it for now. These are my references. If you have any question regarding this, because I know that at the beginning it's not that easy to grasp, just send me an email or tweet or whatever you want. I hope that you enjoyed the presentation, and now it's time for questions. Any question? There is one. Can we have a mic over there?
Hello, thanks. Thanks a lot for the talk. Good question. How do you believe that reactive programming compares with things like promises? And I mean, in promises, it's very nice where you can, chain requests. But yeah, I've seen that there's a lot of struggle when you try to do similar things with reactive programming. So, would you go one way or another, or you could combine the two?
Yeah. So promises are interesting because are used mainly for asynchronous programming. Here we are leveraging a different concept. Here we are leveraging the concept of I have a channel, I need to communicate with different objects inside my application. Yes, I can replace a promise with an observable, but I can't replace very often an observable with a promise. Because the real thing is the promise, yeah, I can deal with the synchronous data, but again, I'm not leveraging the real power of a stream, so that I can merge with another stream, I can split it up, I can do a lot of things, and everything in a functional way. And the library, in particular XJS or Xstream or MobX, are giving us a lot of this utility out of the box. So you just take your library, you put inside there, and you don't use only for communicating with, I don't know, HTTP request or, I don't know, writing inside your operating system or stuff like that. You can use basically everywhere, also for flowing the data across your application. And it's another interesting thing compared to the promises is that potentially an observable could be canceled, and the promises doesn't. So that's another thing that you can use, and it's a main difference of between observables and promises. But definitely a good question. Anyone else? Cool. So thank you very much for coming, and enjoy the conference.